So welcome all of you and have a good morning. So before we start, we are going to discuss about Python in today's session. I am Amit Ranjan and I have been working as a big data consultant and developer mostly. So I have been working in Python, Java and Scala along with frameworks of big data for last more than 5 years. Okay, just a moment. So please open your Jupyter, every one of you. And I'm also launching my Jupyter so that we can practice together. Today, our major focus will be on database connectivity. And it's quite simple to do, but still we'll see how it is done. Meanwhile, I think everyone has got the link for the Google Drive link. If in case you don't have the link, I'm going to share it. I have uploaded a couple of documents over there. Yeah, so this is the link I have shared on the chat. You can use this link and you can download a file called as database connectivity. We will try to work on that particular file. Okay, so you all can see this is my screen, the notebook in the Jupyter, and this is my browser. You all are aware of this. So it contains some files, and this is basically the place, the browser basically on my Windows machine. So I am inside documents, Python scripts. On your machine, you can be inside a different directory. So what we are going to do is we are going to learn about a few things like modules. We will also talk about inheritance, and we'll also talk about database connectivity. So, okay, do we have anyone who is not aware of inheritance? You are aware of classes and objects, the methods which we have been discussing in the last couple of sessions, right? How to create class, how to create object, how to access the method of an object. Okay, that's good. So suppose we have got a class called as a calculator, calc, something like this. And this class contains a function called as some function say add, and it takes one argument two arguments x and y, and then it returns the addition of x plus y, as simple as that, a simple function. Later on, we decide to use create one more class called as scientific calculator. What it will do is it will take two arguments. It will use function add. It will, and then it will check like if x is less than 0 or y is less than 0, it will return 0. Suppose our logic is x and y both should be greater than 0. If any one of them is less than 0, then both are invalid arguments. Suppose this is our business logic. Else we will return x plus y. What happens is, and suppose this calc class has also got a function called as multiply of x and y, and this will return the multiplication of two numbers. What happens in inheritance is it's basically code reusability. It's most of the time used. We have got a class, and then we use all the code of this class to create a new class. This is called your parent class, and this is called your child class. Technically, this is called as superclass, and this is called as subclass. All the code, which is all the code methods which is there in the parent class, it is also accessible in the child class. The format of inheritance is quite straightforward in Python. Whenever you create scicalc, you just use calc. It simply means this scientific calculator class is extending the calculator class. This is the logic. This is a syntax. In Java, you use extends. or if there is an interface, you use implements in Python. This is the way. Now, one more thing is you can create something like x is equal to, you can say new scientific calculator. You can create an object of scientific calculator, which is x. The point is, if you call x dot add and then you pass two numbers, which add will be called? There is add method in the subclass, and then there is add method in the parent class as well. So this feature is called as method overriding. What happens is all the code of the parent class is visible in the child class. Like child class, this class has got access to this function, this method, as well as this method. And child class has then its own method, which is add. So this add and the add of the parent class both have same structure, same syntax. So the previous add, which is coming from the parent class, will be overridden and you will be using the add of the child class. So this will invoke the function of the child class. And this feature is called as method overriding. It's a purely object-oriented programming concept. In the previous session, if you remember, we also talked about the functional programming aspects of Python along with object-oriented aspects. So let's try to see this. And yes, so one thing I have missed out is, do you observe anything which I have missed out in the function definitions or in the function structure, in the function syntax? Do you observe anything which I have missed out? Okay, I'll give you a hint. What is the difference between a method and a function? What is the difference between a method and a function? We have discussed this before. Methods are bound to class and can be accessed via objects, while functions are a standalone feature. Exactly. This is the difference. Functions and methods have the similarity. They perform some operation, they perform some logic. But the functions which are the part of the class, they are called as methods. So here, what you see is the add, the multiply, all these are methods. These are special functions. So do you remember what is the first argument to the method? Since they are inside the class, so the first argument to the method is the self-reference. True. So here I have missed out the self-reference. So I will add the self-reference once I go to the coding. Self, we discussed, it is equivalent to this keyword in Java, where you refer to the object who has invoked that particular functionality or that particular method. So what I'm going to do is here I'm going to create a class, calculator class, and this will contain a method called as add. If you want, you can also do this along with me, and here I'm going to get return x plus y. Then I will create one more method called for multiplication. So if I want to run this, I can use run cells. So nothing to do here. I will create one more cell below for scientific calculator, which is basically inheriting the calculator class, and then I create delf add. So I think you understand this is the shorthand representation for if else. So in this representation, I'm not sure whether I have discussed this before or not. What happens is in Java, you have got this kind of syntax for a shorthand representation for if else. Here in Python, what you do is you give if this is the case, then you return this particular value. Else, if this is not the case, then you return this particular value. So that is a shorthand representation. You can also use blocks of if and else. That is also fine. So what I'm going to do next is I'm going to create object. So if I run the cells, you will see the output is 5 because we are adding 2 and 3. That's a straightforward. What I'm going to do is I'm going to pass a negative argument and see how it behaves. X dot add -2 and 10, like this. If the logic is correct, if this particular add function is getting called, I should get 0. If the add function of calculator class is getting called, I should get 8. So let's see what do I get. If I run this, I get 0 because one of the argument is negative. On the other hand, if I create an object of the calculator class and I perform y.add of -2 and 10, this is going to give me 8. So you should observe the difference of the inheritance, or I should use a different name like scientific object, right? X is an object of scientific calculator. Okay, so and a good practice will be to get the result into a variable and then print the variable, like print result is equal to this. Okay, so now I can run all the cells, and hence this is the result we are getting of all the blocks of the code which we have written. Okay, so what I would like to explore, I mean, I request you to explore is, in Python we have seen about classes, objects. So there are a few more things to know. I mean, we can discuss this, but since it's not that commonly used, because Python is not essentially meant for performing object-oriented programming. We can do that. We can create classes, object, inheritance, and overloading, overriding. All these things can be done. But the main use case of Python is to perform functional programming, and you will be doing that quite often. Or to perform, well, what we have seen till now is it's more about writing the logic, expressing your logic in the Python. That's more important. There is less importance given to the structure what we follow. For example, if you are coming from Java background or any other background, there is, first of all, in Java you don't see any interactive shell. In Python you have the interactive shell. The lines of code you write in Python is way more less. The functionality and extensibility you get in Python is way more high. So the learning curve for Python is very smooth and very less steep. You need not to know the complexities of programming. But still, if you are interested to know more about Python, what I will request you to do is just get some idea. Just it will take 5 to 10 minutes of your time to know about what is abstract class. It is a concept of object-oriented programming, and how to create static methods in Python. These two things you can explore if you want to know more about it. And one more interesting thing in Python is you can do multiple inheritance. Like in Java, it is not possible. In C++, it is a possibility. Like there are two classes, and you can create a third class which is inheriting from both the classes. If you are coming from Java background, you know this is not possible in Java. You can do that with interfaces, but not with classes. But if you have got two classes, you can inherit both at the same time using multiple inheritance. So these things you can explore. These are quite optional for you, but if you are interested, you can know about this. What we will talk now is, we will talk about modules. So the thing is, what exactly is a module? Module are essentially Python files. which contain some kind of classes, or they may contain methods, and you can access them from some other Python file. So it is possible that you create a Python file which contains classes and methods, generic classes and methods in this. They may also contain functions, that is the standalone functionalities. And you can create this, suppose this is your main Python script where you are writing your business logic. So your business logic goes in this particular Python script. You can take the functions which are available in the other Python file. You can use the classes, you can use the methods here. Not only here, there could be multiple application files written in Python, and all those files can take the advantage of the classes and functions created in the previous Python file. So basically, if we observe that some kind of functionality is quite common, it is going to be used across multiple places. So this reduces the development effort, and it also reduces the lines of code. You can create a reusable script or a reusable Python file which can be used across different programs. This is the logic behind this. In other programming languages also are there. I'll again take the reference of Java. In Java, you create packages. So there are multiple packages. Each package is one unit of some activity. So suppose you create one package called as utility package, and then you create your own package. Suppose my organization is there, my org package. In this utility package, you can create different classes or different Java files. Then again, there are different design patterns. I'll talk in a very simple sense. Like you can also create one package for database connection. In this particular Java program, you are handling the database connection, how to create a database connection. You can create one more class for file handling, like you want to read from a file, you want to write to a file, what kind of file, how do you want to read, all those functions you create here. And you create one more class for email, like you want to send an email, you want to customize the behavior, so you create different classes. Now it's quite interesting to know that this DB connection or file handling or email, these kinds of features can be used across different files. Suppose you have got one program that reads from a database, then performs some business logic. Like suppose if it is your financial domain, then you observe like which users have got a high outstanding balance, which users are a regular payee, which users are have applied for a credit card or a debit card, something like that. You process the data and then you send the email. Suppose you can have a different Java program where you perform some other functionality, like you detect whether a new file has arrived or not. So you detect for new file and then you read that particular file. And if the file may contain the balance history of different person, different customers. And after reading the file, you either push the content to the database. Suppose this can be the behavior. Now you can see like reading from a database is here also. Communication to database is here also. Reading from a file is here also. Sending email is here. So there are different actions which should be quite generic because they can be used across different programs. So you create those utility functions quite separately and place them in a different package so that you need not to modify them at all the places. Suppose the database has changed, database connection string has changed. So you need to make change only in this file. You need not to bother about here and here. So basically these files expose some kind of functions, some kind of API to interact with the inner layer. In other words, if I talk, there is a business layer and then there is a data layer in most of the applications. And the data layer is responsible to create connections to the databases, and business layer communicates or uses the data layer. So because there can be multiple files or programs or applications in the business layer which use the same data layer. So you need not to make modifications to all the business layer scripts. So that increases the uh, extensibility and the uses of a particular application. Well, what we are going to discuss here is there are many modules which are available. You will be using many of them, like there is a Panda module, there is Matplotlib, and there are modules. So these are some external modules which are available for performing some statistics over the data for which you have joined this course. So, and then there are many internal modules as well. So the internal modules are like sys module is there, OS module is there. For operating system stuff, OS module is there. For system specific stuff, we have got sys module. And so these are some of the interesting modules about. Then there are modules for hashing, and we have got modules to make connections to the databases. So we will see that. The first thing is, if you create a module, if I just go back a bit, I discussed a module is basically a Python file. So what you can do is you can create your own module as well. So what I will tell you is, first of all, a module is .py file. It has to be placed either in the Python library location, wherever you have installed your Python, there is a lib location. You can place your module over there. This is the first place to do. Or you can place the module in your present working directory. In your present working directory, you can place your module, like the directory in which you are working. Keep the module or the Python file over there so that it is accessible. Or third thing is, there is a variable called as Python path. You can use this variable and you can refer to the location where your Python script. So you can refer to the directory where your Python script can be found. So these are the three options available where you can place your module. What can be the content of a module? Very simple. What I will do is I will create a module called as demo.py. This is my script, Python script. To begin with, I will create only a function called as def print message. And what it will do is it will simply print hello world. Obviously, we can do a lot more complex things, but to begin with, this is the way. That's it. And I will save it. Where do I need to save it? One of these three places. It should be available at one of these three places. For simplicity, I will save it in the present working directory. Then the content of this script is available to our program. In our program, what I will do is I will use import, then the name of module. The name of module is the name of the file without .py. So if the file name is demo.py, the module name is demo. And then you can access the classes, the content like this. You can access like demo.what print message. So this will call the function print message inside the demo. Or if you want, suppose this particular module may have lots of classes, lots of methods. So an alternate way to selectively import from the module can be, you can use from demo import what do you want to import? You can import a class, you can import a function, whatever you want you can import. So you can, suppose if you want to import a function, you can use print message, and then you can call this function without the name of module because you have already imported it. So these are the two ways of calling the same thing. So let's try to see this. So first of all, what I'm going to do is, let me show you. This is my Jupyter notebook. So I can save it as, so I'm going to I'm going to close it. So this is the Python script. This is my current working directory, and in this current working directory, you can see I have created a demo.py file which contains a method print message hello world. That is the content. And what I've done is I have saved it here. You can see demo.py. If you want to read the content, it's the same. This is the content, demo.py. And this is my current, the present working directory. If I go to new and choose Python 3, I can very well say import demo, and then I can call the function demo dot whatever is the function print message. If I run the cell, I will get hello world because it is printing hello world as expected from the script. The other way to do that is you can call from demo import the name of the entity you want to import. And if you run the cell, you will get the same message altogether. So these are the ways to do that. This is how you can create your modules. Now, the thing is, there are many modules which are available by default. One of the module is the OS module. One of the module is sys module. So I'm going to show you a simple use of those modules. Suppose you want to know what is the version of Python you are using. So you can say you can use import sys module, and sys module has got a function called as version or member like version. Let me check. So this is the version. So the version is 3.6.1. This is the Python version, and the other details about the version of Python we are using. Similarly, if you want to know in which directory we currently are, you can use the OS module and say os.get current working directory. Get CWD, this is the function. This will give you the current working directory. So if you run all, you see the current working directory is this. This is my current working directory. So there are many modules which are available internally, and you can also, so suppose you want to detect whether a particular file exists or not, you want to create a directory, you can use OS module for that. And okay, so basically there is one more module called as NumPy, which you will see later on. In NumPy module, you can get a matrix of diagonals. Suppose you provide a diagonal as 1, 2, 3. So you will get a 3 by 3 matrix which contains the diagonal as 1, 2, 3. So you can see the modules make your life quite easy, and they also promote the use of code reusability. So in this segment, we talked about how you can access a module, how you can create a module. Yeah, so basically for this, there are documentations available for modules, like which module has got what kind of functionality. So you can have to refer to the documentation to know more about a module. And with practice, you will come to know like there are many things which can be available in what module. For example, like if you're coming from say Java, if you want to do collection related operation like array list or hash map, something like that. So you know that java.util is the package to go for. Similarly, there are different packages of Java. So one thing is with experience, it will come. And the second thing is for every module, there is a documentation, which will give you more idea about that. So is this what you were asking, Karan? Okay, so now I will ask you to do some kind of a operation, some kind of classroom stuff. One thing is basically create a module. The name of module is file handling. In this module, create two functions. One function will take the file name, and the first thing it will do is it will check if file exists or not. Whatever file name, basically the path of the file which has been sent, does that exist or not? If it exists, if it does not exist, then it will return some kind of value like some message like does not exist. The second thing is if the file exists, then it will tell how many number of lines are there in the file. This is about one function. The other function will take a file name. Here also it will check whether it exists or not. It will check whether the file exists or not. If it does not exist, then I have to return some kind of failure message, something I have to handle that. And if the file exists, basically it will take two arguments, file name and one integer, which is n. So if the file exists, then it will return first n bytes from the file. First n bytes from the file, okay? If the file exists. So first of all, let me know on chat. Can you do this? This is about file handling. So we will create a module so that the functions of the module can be reused across different context or across different programs. So we have to create two functions for file handling. Any segment or any logic which you think will be difficult to implement to you, we'll try to do this now itself. Let me know if there's any issue in here. How to check file exist? Okay. Any other issue you think can be there? How to read the first n bytes of a file? Okay. So try to search on Google. Two things. The first thing is how to see if a file exists in Python. And the second thing is how to read the first n bytes of a file in Python. Try to do this. You will get the answer, and I think you should be able to understand how to work with that answer. Try to search it. You can also check, you can also practice with that particular result in your Python shell or Jupyter notebook, whichever suits you. So do you see anything like OS module, os.path exactly? And then which function of that path? Yep. So that will return either true or false. That's true. So similarly, you can also check for the existence of a file or existence of a directory. You can check in a similar way. So what I'm going to do is, first of all, you see my my file, right? Is there anyone who is trying to practice along with me, who is going on the line? Because I'll request you to do this. You know what is the logic we want to do. This is the logic. So please go ahead, create your module, start to create your Python file, no matter it works or not, but try to do that. Okay, not a problem. I will be idle for some time, at least I think for a few minutes. So just create a module with two functions. Okay. This is the page where the module was created. It was very simple, just a message and a message, just a function and a message. So Okay, so I got a piece of code from Padam. Okay, so I'm going to discuss on that. Okay, so this is the code shared by Padam. So there is a function file name, gets a file name, okay, and os dot path is file. Okay, okay, so you have to import os dot path in the first. Then you open the file for reading and you return the length of file. Okay, this is the length of the lines true, and except no, you will not get exception because this if see this particular function will return true or false. So there is no else. Instead of try and except, you can use if else basically. So if you want to use try, then do not use this part. No, because you try to open a file, and if it does not exist, then you will get exception. But if you are using something like if, so this particular thing will return either true if the file exists, or it will return false if it does not exist. So if you are using something like this, then you have to use if else. Okay, this part is correct. These two are fine. Then read file, then you are again the same thing here. You can use if else. If it exists, then you get n, and you are reading the first n bytes, running it true. That's fine. So you have done most of the things correctly. So I'll use some small modification. Okay, so the first modification is I'll use os.path, then I'll use uh, like num underscore lines, number of lines in this particular file name. And then I'll not use try catch. You can use try catch, but the logic will be slightly modified. And then you can do something like this, and then you can call else. Else you can return this. You don't want to print, you can return, or you can print whatever you feel like. You can do this. Both are fine. And then you want to read file name, then n, and here also, yeah. Okay, so what I'll do is I will save this as a module. Okay, and I will save it inside my current working directory. I can say like file module. Okay, file module dot py, and let me save as a Python file. Okay, okay, so let's start to work on this. I will create this, and then I can say import file module, and then suppose my file name is equal to some string. Okay, so let me choose a file. Suppose this is the file I want to choose, so I can take the full path of the file. Again, backslash is a escape character, so I am going to use 2 backslashes to escape the backslash because it has a different meaning. The file name is database. Ouch. This is a file in my machine. And now what I'll do is I will call the function file module dot read file, and then I will pass the file name. Let's see, and I also pass, say I want to read the first 10 bytes. So let me run this, I see inbuilt DA, the first 10 bytes are getting returned. So Padam, your logic is working absolutely fine. And I suppose this is my result. And I would like to print. Okay, so let's try to run this again. So this is the result. That's fine. Now what I'll try to do is I will try to read a file which does not exist. Suppose I remove this .txt. This file does not exist now. So now if I run the cell, the result is none. I'm not getting any result, but I'm getting a message like this file does not exist. So that's perfectly what we wanted to do, isn't it? So that's nice. Okay. So it does not exist. That's good. Now let's check for the num lines feature, and let's see how it works. So I'm using this particular file, and I'm using num lines, and the number of lines will be integer. So let's see the result. What is the result? So result is 72. It means the file contains 72 lines. Let me quickly check. This is the file. If you see here, it contains 72 lines, right? So this is the file I was trying to refer to. So basically it checks the number of content where \n is there. So it is giving you that particular number of lines. Yeah, so this seems to work fine. Any questions over here from anyone? Is this clear? This is the module. No, yeah, this is the module which we created. It contains 2 functions. Okay, so please respond on chat if this is fine and we can proceed to the database connectivity. Okay, so the next thing is about database connection. It's very straightforward in Python. What happens is you can have a database, like this is my database, and suppose this is my MySQL database. You want to make connection to this particular database. So first of all, you have to make a connection. And whenever you make a connection to the database, there are a few essential details you provide. The first thing is, where is the database located, the machine? And the second thing is credentials, which includes your username, your password. And third thing is which database you want to connect to. A particular database server may have lots of databases. So you have to create a connection first. After you create a connection, you will use a cursor to execute your queries. Your queries can be a select query, insert query, delete query, create query. There could be lots of database related queries which you can execute and get the result. So what I'm going to do is basically in my machine, I have got one instance of virtual machine running. In the virtual machine, I have a Linux operating system. I have got a community enterprise operating system, CentOS. So first thing is and I also have got MySQL installed there. So the MySQL is accessible with the root user, and the root user is passwordless. It does not require any password. I have created some databases. I have created some tables as well. You can download the virtual machine. It's the Acadgild virtual machine. This is essentially one Acadgild virtual machine. You can get it from our operations team. Else I will also share. Basically, this is meant for Hadoop training. I'm going to show you one example here. And I will again show you one more example, and that will not require any virtual machine. You can run on your machine also. So I'm going to show you both examples, and I'll try to get the link of the virtual machine which from where you can download. I'll share the document. And if the document I share does not work, then you can get in touch with our operations team. They can share you any updated document if they have. So first thing I will do is, the first thing is I will install the connector. Like there are different connectors for different databases. So for MySQL, I will install the MySQL connector and then I will use it. So let me show you first. This is the virtual machine of Acadgild, which is CentOS version 6 is running. And I have made connection over there. So the first thing I'm going to do is, you have to install the MySQL Python connector. In my machine, it is already installed. So if I try to install this, username and password is Acadgild. So nothing to do because it is already installed. So what I'll do is I will go for Python 3. You see the Python 3.5 release is there, Python 3 version. This is the command line. And let me talk about the small code which I'm going to execute. I'm going to import this. You already know what is this. This is a module. This is basically an external module. Once you install this particular connector, this module will be available. Then you create a connection to this particular database. The machine where the database server is running, it is the local host. It is running on the same machine. Else you will have to give the name or the IP address of the machine where you want to connect to. The user is root and database is B1. You can choose a different database also. So you pass the arguments. These are called as keyword arguments, where you specify some property is equal to some value. You can see like this is your property and this is your value. Then we create the cursor object. This cursor object helps us to execute queries over those connection object. So you can execute like select a star from the company or select, this is a table which exists. Then once you execute this on the cursor, after you have executed the query, you can call the function like fetch all or fetch one. Fetch one is like getting only one record. Fetch all is getting all the records. So we are getting all the records and we are printing it. And finally, we are closing the connection object. So let me show you how it works. The first thing is, if I go MySQL -u root, like logging in as root user, if I show you the databases, these are the databases in my MySQL database. And if I use B1, this is one of the database, like use B1. And if I want to show the list of tables, we can say show tables. Company is a table. And if I want to do like select a star from company, so you select, there is a name and there is a location, and then these are the two values in the database, in the table. In the Python 3, what I'm going to do is, the first thing I am going to import the MySQL DB. No module, oh sorry, I think I installed that in a different version of Python. Okay, import MySQL DB, and then I'm going to make connection to that particular database. So if you see DB, what is DB? DB is basically a MySQL connection which is open to this particular machine. This is a memory address. So this is our connection object, the DB, which we just created. And then you can create a cursor object to connect to that MySQL and execute any query which you want. So suppose if I want to do like select a star from company. So now if I say for x in cur dot fetch all, getting all the records, I want to print x. So see, you are getting all the elements or all the records from that particular table. So creating a connection, getting a result is quite straightforward. Now, again, if you want to do like select a star from the company and you want to do like fetch one, and then you want to print X. So it will fetch the first column. So you can do like that. Sorry, not the first column, but the first record. Fetch one is the first record. So you are getting Acadgild and Bangalore. So basically this is the first record. Okay, so now this was about connection to the MySQL. You can again connect to different databases like Oracle or Postgres, and there are different connectors available. One more interesting way to do that is using SQLite. There is a module available called as SQLite 3. What happens is it creates one embedded database. Embedded, or you can say a local database. You can run this on your machine. You don't need to have any MySQL or already installed. What happens is it creates a database in your current working directory. So whatever is your present working directory, it will create a kind of file which contains all the elements of that particular database, all the tables of that particular database. First of all, I will show you, this is my present working directory. See, there is nothing called as .db file. You can verify. Once I create the local database, it will create a .db file that will come up later. So what I'm going to do is, let me show you. I'm going to import the SQLite, which is an inbuilt module. And then I'm going to use this module to connect to one local database, and I can choose the name of the database. If this database exists, it's fine. If it does not exist, it will be created. So you get a connection like is CONN, and then you get a cursor object. So this cursor object will help you to execute queries. What could be the queries? Very simple. You can execute query like, you can create a table. I'm creating a table of stocks. It contains the date, transaction, symbol, quantity, price. So these are text types. Text is like your string types. Real is your numeric types. And then I am executing the query, insert into a stocks, and I am inserting these values in the different columns. So this is your standard SQL query to work with a database. So this record will be inserted, but finally we would like to use commit. Commit will flush. It will make sure the changes have been saved. When you are done, you can close the connection object as well. So let us try to work with these basic queries in the beginning, and then we will talk more about it. So what I'm going to do is, let me create a new notebook. And then inside this notebook, I'm going to run these. Okay, so I'm going to run the cells. Nothing is going to get printed here, but here, if I refresh, you will see something like example.db file. Oh, you will see example.db file has been created. If I go back to my file system, and if I just quickly refresh and see, you see example.db file is there. If I try to read this file into using one of the editors, then if I try to read this, the syntax is such like it is a binary file, so the content will not be displayed if you try to read from this particular text editor. But the content is there. Whatever we created, we can make one more connection object and we can read from the database. How to do that? Let's try to see this. So what I'm going to do is oh, no, this should not have been executed. Actually, I was trying to execute it again. See, if I try to execute again, create table stocks, it is going to give me error like table stocks already exists, because it is there. I should not recreate it. What I'm going to do is I am going to create the connection and cursor, and now I am going to have select a star from stocks. Select a star from stocks. So this is the query I want to execute. Since it is a single line string, so you can use a double quotes or single quotes like this. And now if I say for x in c dot fetch all, print x. Yeah. So if I try to run this, you get the result. This is the entry. Very similar to behavior as connection to the MySQL database. We are getting all the records. So one thing is you can, I'll tell you one more operation over here. Suppose you have got a list of tuples which you want to insert in a single shot. Like this is your first tuple which contains elements. This is your second tuple and this is your third tuple. So if you have got a list of tuples and you want to insert all of them in a single line, you can call the function execute many. So in the execute many, what I'm going to do is I'm going to use insert into this particular table the values. These values will be taken from this particular list. So purchases is my list. You can verify this is it. And basically this is a list of tuples where every tuple represents a record. And all of these will be inserted. You can commit the cursor so that the changes are not lost, and then you can perform your SQL queries like select a star from this table, order by this. I mean, any SQL query which you want to do. Moreover, if you want to get data from the table, you can use select a star, then you can give the table name and you can make a query like where symbol is equal to this particular symbol, where symbol is this RHAAT. So in this query, it will give you all the results of the table where symbol equals this particular symbol. But this is your string substitution, right? So string substitution is considered not secure enough because it can cause a problem of SQL injection, where your variable which you are passing may contain some harmful SQL messages or statements. So we use something like prepared statement, if you know in Java. So we use question mark symbol and then we pass any list or any tuple which can be iterated. So what I do is I create T, which is a tuple of symbol, and it contains only one element, which is RHAT. So this element will be passed as a symbol value to this, and this is quite safe, quite secure enough, and this is what we practice. So let me try to run this and see how it works.
So
Okay, so let me try to execute all. Oh, oh, sorry. this has to be like this, print row. I cannot close it. Oh, the database has been closed. Okay, just a moment. Okay, so I have executed all those blocks one by one. Uh, so you can very well see like the first block was creating a table, the second block was reading from a table, the third block was reading where symbol was equal to RH80. You could have printed the content as well. So if you do fetch one, it will give you the one element which matches the condition or which is returned from the query. Then we inserted 3 more records. You can see very well here. And finally, we are executing select a star and we are getting 4 records because 3 records were already executed, were inserted. So what I'll do is I will slightly modify it. And then I will upload in the Google Drive. Okay, so I've uploaded in the Google Drive. You can download and you can do the same on your machine. So please practice this. Let me know if it is working on your machine. You can use the Python shell, interactive shell, or you can use Jupyter Notebook. Okay, so Padam, you wanted to ask this. I'll tell you. See, if you execute this statement where there is a string substitution, it will become something like this. Select star from stocks where symbol is equal to, then in the single quotes, the value of symbol. Suppose you have passed the value of symbol as RH80. So this will be substituted. Clear, Padam? Is this clear? Till here, I'm going to proceed next. This is the variable substitution. Okay. Now, suppose there is some hacker or there is some illegitimate user, and instead of passing this particular argument, he passes argument like this. Say, the argument he passes is RH80 single quotes semicolon drop table, some table say XYZ. Okay, and then single quote. Suppose this is the argument which he passes. So if you substitute this variable here, what will it become? It will become like select a star from the table where symbol is equal to single quotes, then RH80 single quotes, and then what is next? Next is drop table, something like this. So what will happen is it has the potential drop table XYZ and then single quotes like this. So this is going to drop, it has got the possibility of playing with your internal things which the user may not be supposed to. So it is going to drop your table or do something else. So by manipulating the variable which is getting passed. So this is quite insecure. That is why it is not practiced. What we do is we give a question mark. So in this question mark is strictly this value, this statement will be compiled, only this statement will be executed. And inside the question mark, if you get something like this, so in this entire value will be passed in this particular in this particular uh, placeholder. So basically this is your placeholder. So it makes sure that whatever value t contains, that is going to be executed. It's not going to execute anything else. This problem, which was earlier, you can see in line number 30, this problem is called as the problem of SQL injection, where you can inject some malicious SQL queries as your argument. Is this clear, Padam? No, it has to be tuple. What happens is your t which you are passing, it has to be a tuple, and the syntax we follow is the actual argument is the first, and then we give a comma, even if there is no further argument, because all the content of the tuple will be traversed. So it has to be a tuple. If you place it as a single string, then all the individual characters of the string will be traversed, which is not the thing which we want. Okay, so this was about it. Are you practicing this? Please let me know on chat if you are practicing this database connectivity on your Jupyter or Python shell. I have shared the file on the Google Drive. Please check if it is working on your machine. So one thing I would like to announce is, like, this is my last session. I was available here for the Python coverage. So I hope you got to know about the elements of Python, why do we use Python, the structure of Python, and when the structure of programs in Python. You must have observed, like, it's really an easy to use language. I am basically a big data developer, and I'm also trying to know more about data science. So whatever you learn in data science, keep on sharing. And from the next session onwards, the data science specialist will take the upcoming sessions about whatever topics are to come. In case, so do you feel comfortable enough in Python? Because this is what you will be using in the time to come as a part of the course. The best way to learn Python or any programming language is to do hands-on. That gives more confidence and more comfort. So are you getting more some level of comfort in Python? We had 5 sessions on Python. Yeah, please give more time. It's a fun language. It's a very friendly language. Like what I'll tell is, suppose if you open your command prompt, if Python is installed, you can simply type Python and go inside the Python shell. That will be way more quick to do hands-on. Like you can just type x is equal to ABC and then print x. As simple as this, you can do a lot more interesting stuff in this command line. So this command line is very quick and easy way to do that. But yes, practice is quite required. But as compared to many other counter programming languages, Python has got quick learning curve, I would say. Actually, I have been working on Java, and even in the graduation, in the colleges also, I had no idea about Python. It's so high level, it's so easy. But I got a chance to work with Python, some amount of Scala, some amount of Perl, and I find Perl is also a very good language. For some time, I worked on Ruby for a few days. That is also quite interesting. But I do have some amount of affinity towards Python. I don't know why. If you practice, you will also feel the same, I think. And then Scala, yeah, Scala is also a very good language. It's also functional. But for data science stuff, whatever data scientists I have met, they use either R or Python. So and Python is very accepted. So the time which you give in Python is really going to be valuable down the line. Okay, so is this working? The SQLite, is it working on your machine? Have you tried to work with this on notebook or Python shell anyway? If you want to refer to the book in Python, the first thing is I would say whatever in the 5 sessions have been discussed, try to be very comfortable with that. The first thing. Books are there. There are learning Python. There is programming Python. These are the two very good books. They are available for their ebook versions are also available. And if you do not mind any kind of piracy, you can get it for free also. They are available for free download. The first step is learning Python, but it's a huge book. I mean, it will take at least a month to completely go through the book, because it contains, I don't know, but maybe more than 500 pages like that. And then there is programming Python. If you want to delve deep into Python, if you want to be a Python developer, these are the two books you should refer. They provide a complete and thorough coverage. But what I suspect is, since you are going to be a data science role, you are not going to be a hardcore Python developer. You should have some idea of Python. So there is a website called as pythoncourse.eu. I would suggest you to go through this website. It contains the Python topics explained one by one. But again, it depends on your use case. Like learning these two books will take somewhere close to greater than or equal to 2 months. I think, because we all are working professionals, like giving 1 hour or 2 hours every day for 2 months to get Python. I mean, you have to decide which road you want to go. But this course, it's like, suppose you want to know about classes, so just read about classes. If you want to know about inheritance, just read about inheritance. If you want to know about a specific topic, so you can just get it like on demand topic. You want to know about this particular topic only, so you can do that. But yes, these are some good sources for Python. And then there are countless numbers of Python materials, blogs, courses. So, but these are the ultimate resource one can have. From tomorrow, the sessions are going to start on statistics, I guess. So if possible, I would also like to join the session, but as a participant, like to know more about the statistics. So hopefully we can be together, but I will be more on the receiving end. Let's see how it goes. Yeah, but if you receive any problem down the line in future, you can certainly get in touch with our Acadgild team. They will love to help you. Okay, so that is all from my end. Thank you all for joining the session and giving us the opportunity to share our learning. So I wish you constructive course ahead. Okay, so thank you all. I'm closing the meeting. Do share your feedback and your ratings on the dashboard. Thank you once again.